First thing I need to tell you about in this video about vectors is what the difference is between a vector and a scalar measurement. So with a vector measurement, it has size, but it also has an element that tells you the direction. Whereas with a scalar, it's all just about the size. So some common differences between scalars and vectors. So for example, speed is a scalar unit of measurement and its vector equivalent is velocity. So the difference between these two is speed is just how fast you're going, but velocity is not just how fast you're going, but in what direction you're going as well. These are examples of what are known as column vectors, and hopefully you will have come across these in transformations of shapes. So if it is in the context of transforming a shape in some way or another, the top part tells you how much to move it forward or backwards, in other words the X direction. The bottom number tells you how much to move it up or down, the Y direction. Here I'm just going to show you how simple it is to actually do three different things with these column vectors, starting with adding them. So literally you just add the X parts together, so that will be 5, and the Y parts together, which will be 12, and hey presto, you have this new vector. Okay, so the first one could be a line doing this, the second one would be a line doing this, and the result that you've got is the line doing this. Okay, just to put it into some visual context. But in terms of the actual number crunching, it's really very simple, as I've just said. So you won't be surprised to see that this takeaway one works exactly the same. So 7 take away 3 is 4, 4 take away 2 is 2, and there's our resultant vector. Third example here is an example of when we're going to scale up a vector. So this should remind you of algebra and brackets, and you're going to treat it exactly the same way. Namely, that 3 is going to multiply what's inside the brackets. So we'll have 3 6s, which is 18, and 3 minus 2s, which is minus 6. And again, just to give you a bit of a visual, so in terms of what this would look like if we were doing a diagram, so the original 6 minus 2 vector might be that, and then the 18 minus 6 vector is simply 3 times as long, but in the same direction. So you've become familiar with column vectors like the one you can see in front, but there's another way to write vectors as well, and that's using unit vectors. And unit vectors, as the name implies, means that the size of each of the vector is just one unit, whatever you're working with, and an I means that it's one unit in the X direction. A J means it's one unit in the Y direction, and a K means it's one unit in the Z direction. So this column vector that you can see up here would be written as 3I plus 2J plus 5K. So it's just a different notation. If we have a vector given in this unit vector form, we can use that to find the size or the magnitude, if you like, of the vector, which we're going to call R. R is going to be the square root of x squared plus y squared. If you just have a look at the diagram here and think about Pythagoras, you can see how that works. Now, should you be asked to find the angle of that vector from the origin, then you can see that we can use our tan there. Tan of theta is opposite y over the adjacent x. And this works also in 3D, and so the magnitude of a 3D vector would be the square root of x squared plus y squared plus z squared